Hello class, welcome to the video demonstration for online assessment number 2. We are going to be analyzing a set of data from a joint position sense task to test the encoding specificity principle. So joint position sense is, or your static position sense, is the aspect of proprioception that tells us where we are in space at any given point in time without vision. Kinesthesia, another aspect of proprioception, tells us or gives us the sensation that we are moving, also some indication of how fast we're moving, or more specifically, that rotation is occurring about a joint. The encoding specificity principle states that that memory performance is better when the practice and test conditions match. Right. So the JPS joint position sense task that we used involved positioning and repositioning to a two-dimensional target. So you either actively or were passively positioned to a target as to remember your position in space, relaxed back to the start, and then after a time delay of about 3 seconds, you reposition to that target. So you either repositioned actively to where you remembered that target being, or an investigator guided your arm and then you indicated when you were at that target with a verbal stop. And then your error score was calculated as the difference between the repositioned or the remembered target and the actual target. A negative error score represents an undershoot, and a positive error score represents an overshoot, while a 0 represents you were right on the money. So according to the encoding specificity principle, right, our performance, so lower error scores, should have happened during, say, the active, so where you're actively positioned and then you actively reposition to the target, and passive positioning to the target, and then passive repositioning to the target. So memory performance or performance should be better on those conditions, right, where these two match, versus when they were different, like in the active positioning, passive repositioning, or the passive positioning, active repositioning tasks. Right, so hopefully we will see lower error scores here and here versus here and here. All right, so let's take a look at your quiz questions. We're just going to do some very simple formulas in Excel that you've already seen, but I am going to show you some other tricks. For instance, on question 4, how many right-handed male overhead athletes do you have? I'm going to show you how to nest if functions. Right, and then we'll look at some absolute, constant, and variable error in our analyses. So I'll keep coming back to these questions, but the first few questions are just really about participants, how many, so using the count and count if functions. So let's go ahead and look at our data. My data is going to look a little different than yours, just because I think you have more participants that actually completed the experiment than I do. So I have characteristics, so height, weight, age, on 100 participants, but only 20 participants completed the tasks, and I think you have considerably more on your data sheet. So we're just going to use this for demonstration purposes. So the first thing that I'm going to do is I want to pull in all of the characteristics for these participants over here. So I've gone ahead and added a row. Let me just get rid of this. I want to add a row above, and that's because I'm going to be referring to the columns of data like age, height, weight, etc. I'm just going to pull in that data. So the first thing I want to do is see what columns of data do I actually want. I'm just going to go ahead and take all of them, except for participant ID. But we're just going to go ahead and use age all the way down to overhead athletes. So about 7 columns, 6 columns, it's 6 columns of data. All right, but columns 2 through 7. So B through G. So going back to my JPS worksheet, column 2, which was age, all the way to column 7, overhead athlete. Right. So now using the VLOOKUP function, equals VLOOKUP, open the parenthesis. I want you to look up participant ID. Then I want to select my table array. So I'm going to highlight this first cell, this A1 participant ID down here, and scroll all the way down to the lower right-hand corner for that last data value. press the Shift key and click. So you have this moving line, right, highlighting this data set. Looks good. So from A1 to G01. And let's head back. So that's a comma. So I highlighted comma, back to my JPS data. I want it to reference this cell right here as far as that represents column 2 over on my participant characteristic worksheet. So go ahead and highlight that cell. So JPS data worksheet, cell F1, and then false. Okay, and that's because I want it to return an exact value. True would give me a partial, and we don't necessarily want a partial value. We want to make sure that this ID is intact. So that's why false. We want an exact value. Go ahead and hit enter, and I have age. Now, if I were to scroll down or just go ahead and double click quickly, there returns somewhat of an error, right? This reference. It doesn't necessarily, it's doing basically what Excel is doing is going row by row by row, and we want to lock in some of these cells. So first of all, we're going to lock in this participant ID column. Actually, let's go up here and change the formula. So I want to lock in column A, but I want the row to move freely as it's looking for this participant ID. So locking it in by putting a $ in front of the A. I want my entire data table to stay to be stable. So I'm going to put a $ in front of the column, a $ in front of the row. And then as far as this cell is concerned, I don't necessarily need to worry about the column F, but I do need to worry about the cell. I don't want the cell to consecutively go down the line. So we're going to lock that cell in, and that's false. Right, so now when I copy this formula down, it gives me the ages of my participants. So you can see this participant here, this 1438323, 78 years old. So if I go ahead and pull these, actually what I could do, I won't do it. Go ahead and pull my column headers over, and then copy my formula all the way down. It's a little slow on the uptake on that one. There we go. All right, and I believe that there is a mistake, or there was a mistake on your data sheet, and I do apologize. No matter how many times I look at something, I always seem to have one, or more often than not more than one mistake, but I do believe you had, for overhead athlete, there was a 1 for yes and a 2 for no, and that should have been a 0 because in your data column, and I think most of you picked that up, that you only had 1s and 0s, there were no 2s. So, right. But I do appreciate your patience with that. So you can see, so now I have all of the characteristics for the 20 participants that were in this experiment. Right, so let's just do some simple counting. We just want to know how many males, how many females. So I'm just going to count by participant ID since it's a numeric value. So I have 20, so let's find out how many males. So count if this range of data here, count here, anything in here equals a 1. So I have 9 males. Do the same for females, so count if anybody here is a 0. All right, so 9 and 11 looks good, right? Things are adding up okay. So now, question 4, I wanted to know how many right-handed male overhead athletes do you have? So I'm just going to make a new column over here just because I think it's going to be easier to see. So I want to know right-handed male overhead athletes. So this is we're going to nest if functions. So equals if. And I'm going to go ahead and start because the sex column is actually to the left of the handedness and the overhead athlete. I'm just going to start over here instead of starting with handedness. So, but if the sex is, so if this cell equals a 1 for male, we're on track. So I comma, and then if, again, open the parenthesis, if This cell is 0, so if they're male and right-handed, comma, and I'm just giving myself a space just because it looks a little cleaner. And then another function, so nesting a third if function, if they are, in fact, an overhead athlete, so if that equals 1, then I want to return a value of 1 because we're going to count those ones as individuals that are right-handed male and overhead athletes. If not, then return a value of 0. And we had 3 open parentheses, so we're going to make sure we close with 3. So here's 1, 2, 3. So there is our formula here. And hit enter. And really quickly check your work. So this participant was male, they were right-handed, and they were an overhead athlete. So what you're going to see, though, is when I copy this formula down, you're going to see some ones, some zeros, and a lot of false values. And what that's saying is that in this nested statement, that one of these 2 criteria, whether they were female and they were left-handed, right? So they didn't necessarily meet these 2 criteria of being male and right-handed. And so that's going to return a false value. But you can see down here in the 0, so they were in fact male, they were male, and they were right-handed. The only thing is once we got to this last variable, being an overhead athlete, they were a 0. Right, so they were not an overhead athlete, so this last statement here. But Excel is not going to calculate these nominal variables, this true-false. It's only going to count the ones. So you're going to, of course, have a lot more data than I do. I can easily just say there's 3 right-handed male overhead athletes, but I'm just going to use the sum function to sum this range of data, and I have 3. Right, so that was my answer to question 4. So question 5 is based on, let's look at this, based on the mean absolute error, you're going to rank the performance tasks from best to worst. So best being the least error to worst or most error or highest. So we need to find the absolute error for these tasks. So I'm going to go ahead and insert a blank column between or right after the raw data. So I'm just highlighting and right-clicking insert. Right, I'm just going to call this absolute active, absolute passive. I'm sorry, passive. Right. And then use the absolute function, ABS, of this variable here, and enter. And we can take that all the way down. All right, so just do a really quick check, make sure there's no negatives in this column of your absolute error, and that the negative 10 does turn into a 10, etc. All right, so it looks good. So now what I can do is, because Excel, I'm just copying, Command C, or copy, alternatively copy, and paste. A straight paste, not straight paste special, because it's going to take the formula with it. So what Excel is saying is, oh, okay, you want to take what's on, you want to do the calculation on the cell that's to the left of this cell. So it's going to do that all the way across. So I'm just Command C, Command V, Command V. And then go ahead and scroll down. And so now we have our columns of absolute error. So we want to rank the mean absolute error from best to worst. So since I think if I read ahead, there might be a time where I need the average of the raw or the constant error scores. So I'm just going to go ahead and calculate the average for all of my tasks. So constant error, absolute error, constant error, absolute error, etc., all the way across. And then because I'm interested in ranking only the absolute, I'm just going to highlight this just so I can tell. All right, so according to my analysis, or my 20 participants, they seem to as far as absolute error is concerned, they seem to perform better in the active positioning and passive repositioning tasks. And then the next one would be the active-active, the passive-active, and the passive-passive. Okay, so that was question number 5. We were to rank from best to worst. Now, on average, question number 6, on average, which condition did participants undershoot the target? So this would be the constant error here. So let's go ahead and highlight this in a different color. Let's do blue. Right, and you can have more than one answer, more than one correct answer, and you can see looking at constant error, right, so the average of the raw error scores taking direction into consideration, that participants undershot the target in the active-passive and the passive-passive. Right, so there were 2 correct answers as far as these 20 participants are concerned. Right. The next question, question number 7 on the worksheet, was which condition resulted in the most consistent performance? So remember back from our first conversation about error scores, absolute, constant, and variable error, that consistent performance reflects variable, or variable error reflects the consistency in performance. So, and that's calculated by the standard deviation. So I'm just going to use the standard deviation function. I'm not going to worry about whether it's a population or a sample. So STDEV, and then go ahead and select your range of data, making sure you don't select that average in there as well, like down here. You just only get from here to here. All right, and so go ahead and pull all of those variable error scores across. But there's a mistake here. I just did that for simplicity, but variable error is based on the constant error score, not the absolute error score. So just to alleviate any kind of confusion, we want to get rid of anything, the standard deviation of the absolute error. It doesn't tell us anything. But what we would want to do is take this down to just maybe 2 digits of precision, 2 decimal places. And so you can see that the most consistent scores, it looks like the active positioning and the passive repositioning had the most, our participants did better as far as consistency in that task. So for my question number 7, I would have chosen active-passive. All right, so question 8. Did overhead athletes have more consistent scores on the active-active task than non-overhead athletes? And we are looking, let's go ahead and see. So did they have more consistent scores? So what was their variable error compared to the non-overhead athlete? So for this, I think I need to make some new columns of data and calculate over here. I'm going to calculate over here. So I'm going to say my overhead athletes, I want to report their active-active scores. And then my non-overhead athletes, I'm going to report their active-active scores. Right, so you can do data sort, you can try to cut, copy, paste, whatever, but I think this is going to make it a lot easier. So for this first cell here, I'm going to use an if function, so equals if. All right, if they're an overhead athlete, select that cell, if they are an overhead athlete, so if that cell equals 1, then if it's true, I want Excel to report this score. And if it's false, right, just to avoid any confusion, I don't want to use a numeric value, so I'm going to use an asterisk, and I'm putting that asterisk in quotation. So that's the value of false. So if it's false, if they're not an overhead athlete, it's just going to give me an asterisk rather than a 0. And I'm going to copy that down. All right, so good. We have, let me center this so you can see what we're doing here. All right, so this is centered and this is an asterisk, so that means that they were not an overhead athlete. Are they? Yes, they were not an overhead athlete, 0. Okay, so now we look at our non-overhead athletes. So if equals if this cell here equals 0, then I want you to report their active-active score. And if not, then give me an asterisk. All right, so hopefully, if this cell has a number, this cell has an asterisk. If this one has an asterisk, this one has a number. So just make a quick visual. Looks pretty good. All right, and now we want to look at consistency. So let's calculate the variable error. So standard deviation of our overhead athletes. And so we can just pull this across. Yep, and give me 2 digits of precision. Oop. All right, so it looks like our overhead athletes fared a little bit better as far as consistency is concerned, at least for these 20 participants. And then the next thing that the last 2 questions involve significance. So an alpha of 0.05, which is the default value in Excel. Was the difference between the active-active and the passive conditions significant? So, and I believe on your quiz in Learn, I'm asking to look at the significant differences between the absolute error of these 2 tasks. All right, so let's go back here. It's getting a little confusing. Here's my counts, averages, standard deviation. So let's just go down here. I'm just going to make a little t-test and perform my t-test right next to it. So I want to know if t.test, I'm going to find the p-value of my active-active. So here's my first range. So array 1. And my passive absolute. We go absolute, passive. Make sure I don't take in that mean. 2 tails. And it's a paired samples t-test, so it's a 1 because the same participant completed all 4 trials. All right, I returned a p-value of 0.76. So that is greater than our alpha level of 0.05, so there was no significance. Okay, so it doesn't seem like there were differences in performance between, as far as absolute error is concerned, between the active-active and the passive-passive protocols. All right, now question 10, this is going to be a little bit more involved. Question 10, according to the encoding specificity principle, we should have seen that participants did better on the where the practice conditions match the testing conditions versus where they didn't. So what we want to do is we want to consolidate our active-active and passive-passive data. So we're just going to compress that data into one variable and then compress the active-passive and passive-active conditions into another variable. All right. So I think this is how we're going to do this. I'm going to call these, I'm just going to say that this is the same, and this is where it's different. So this is basically the practice and test conditions are the same, and the practice and test conditions are different. And just to be clean, I'm going to copy my participant ID numbers over here. And then I'm going to refer to cells. So the same, let me think, just want to make this right. Same would be our active-active and passive-passive condition. All right, so let's go find the data. So equals, Let's use our raw data. I want this participant ID in this cell. Okay. So then, because I put the ID numbers over here, let's see if this will. Nope. Okay, ignore that. Scroll down to my ID number. Good. All right. So now I'm going to copy this other set, or copy that set of IDs and put that down here, because so this is essentially this participant. This is their active raw score. And this participant, same participant, I want to know their passive score. All right, and scroll down. We're going to do a quick check, right, to make sure that 1749539, that their passive score was indeed a 4, a positive 4. So passive, indeed a 4. All right, good. All right, and then the different tests. So let's go to our active passive. So, okay, take that down. And then equals passive active. And scroll down. Whoa. Command Z. Okay, and just make sure I didn't miss anything here. Check to make sure that their passive active was a 5, and it was. Okay. All right, so were they significantly different? So now let's just do a t-test. So equals t.test. So array 1, my same, active, passive. Array 2, I'm just going to highlight this bottom cell here, and then shift. Yep. And then 2 tails, independent, or I'm sorry, paired samples, and greater than 0.05, so not significant. So we did not see a significant difference between the conditions where they were the same versus when they were different. So that does not seem to be in line with the encoding specificity principle. Right, so I hope this at least gets you on track. I think your data is going to turn out a little differently than mine, but maybe not. But still, we might not actually see the encoding specificity principle in action, so don't get yourself too frustrated with that. Anyways, do your best, and if you have any questions, go ahead and email me. Thanks a lot.